Good morning, good afternoon, and welcome everyone. I'm Paul Collins, so I'll be your host for today's discussion, Digital Twin Models for Geophysical Surveys, Pitfalls and Promise. It's great to see so many of you joining us from around the world, engineers, surveyors, researchers, technology specialists, all interested in how digital twin technology is transforming, the way we collect, interpret, and manage geospatial and geophysical data. Over the next hour, we'll unpack what digital twins really mean for our industry and beyond the buzzwords. We'll try to explore how these models bridge the gap between physical assets and digital intelligence, the role of BIM and standards in bringing them to life, and of course, some of the common challenges and pitfalls that come with implementation. Our goal today is to go beyond the theory and to share some real world insights and some candid experiences, which is always important. Some practical lessons from the professionals that are with us today, who are leading the way in digital twin adoption. Before we dive in, a little bit of housekeeping. So we have a Zoom webinar, of course, so it's being recorded. We'll have time for questions, hopefully, at the end. But if not, feel free to use the Q&A box as we go. All questions and answers are visible to participants. So let's meet our panelists. Joining us today is Bill Owens from Caltrans, Chief of the Geophysics and Geology branch in Sacramento, California. He's responsible for engineering geophysics investigations statewide in support of transportation projects. We also are joined by Dr. Timo Sarankito. Timo is the COB of Road Scanners Group in Finland. He's a specialist in NDT-based traffic infrastructure asset diagnostics, pavement management, and proactive asset management. And finally, we have Mitch Liddell, who is the GPR platform lead at Tetra Tech in Alberta, Canada. Mitch is a professional geophysicist and has a PhD in earth sciences. So thank you for all being here. So to kick us off, I'm going to stop sharing so we can just see us all. And for our hosts to our panelists to be able to share information with us as well. But to get us started, I'd like to open with a question that sets the stage for our discussion. And feel free to take turns on this. So how would each of you define digital twins in the context of geophysical or surveying applications? Are we talking about the same thing when we use that term? Bill, do you want to start us off?
Certainly. Now, at Department of Transportation, we're engaged in the process of developing building information modeling for infrastructure. This process started. Actually, I can show the video. Let's see. I can share my screen and show everybody.
Cool.
And so we can view, where's my slideshow? We'll start from the current slide. And so we can talk about this process really started in 2021, where Federal Highway Administration released their national strategic roadmap towards advancing building information modeling for infrastructure. At that point, Caltrans was already involved somewhat in doing that. Before that came out, Caltrans had actually initiated a statewide 3D utility database in order to store utility information that's within our right-of-way. So a year later, it became a mandatory process because California Assembly Bill 1037 essentially requires the California Department of Transportation to develop a plan for adopting building information modeling. And so in 2023, we released our own statewide roadmap that puts us into from about 2023 to 2029 to fully adopt it for all structures in California. And so really the digital twin is ultimately a result of this process. And so we can kind of think about where we are here and what is involved in building information modeling. And essentially all of this, you're pulling in all of this information from all of these different sensors, all of these different data streams into a common data environment and putting that into your database. And what that ends up doing is produces your asset information model at the close of your project. And the asset information model for everybody that's involved in BIM is essentially the digital twin. And so that is essentially the data bucket that contains all of that information on that particular asset and is updated periodically, both through maintenance all the way up into decommissioning of that structure. And so from our aspects, we're doing a number of different things. We have about 16 pilot projects that we're involved in. Not me personally, but that Caltrans has adopted to start working with building information modeling and developing these things. And so we on my side, my involvement is essentially as part of the utility locating process, identifying utilities on a project and importing that into the database. So that is essentially, in a nutshell, what we're involved with on the state side.
Hmm. And just an open question for, and for the rest of the panel. So how does BIM and digital twins, how do they intersect in your experience? Where do they overlap, and where are they different? Because we say BIM, I think everyone's kind of comfortable with BIM, and then there's digital twins. So where do they overlap, and where are they different?
Mm-hmm. Now BIM is the process. The digital twin is, as part of the asset information model, is the result of that. So it's really kind of the digital twin is the end result of that entire process. And so nationwide in the U.S., there are a number of DOTs that are starting to adopt building information modeling. I think Colorado is well on its way. You have Utah, Texas, Oklahoma, Minnesota. So there are states that are currently doing that, and Caltrans is participating with those groups. They have annual building information modeling summits where these groups, along with the construction industry, get together and talk about how to develop standardization of data sets such that you can exchange data between private and public. So you can take information that is within the public asset and transfer that over as part of the digital twin to private companies for construction, for detailing, for maintenance, for any of those operations that would normally involve a 2D plan.
Mm-hmm. Yeah, because they both share geometry and metadata. They include spatial and material information.
Yeah,
But the digital twin is dynamic and operational. So
absolutely.
okay.
If if I continue, first of all, I'm at the moment located in Sofia, where there's today is the last day on IRF Europe and Central Asia meeting, and actually we had a very good session yesterday about BIM and comparing experiences, and as Bill said, that BIM is a process, and BIM is it's a good part, but the biggest challenge with the BIM in general is that because it's been developed over the last 20 years, and it works quite well if you are building a new road, but if we are starting to develop BIM only for the new road, so we have to wait for 100 or 200 years when we have a pretty good coverage on BIM's coverage on our transportation infrastructure. So the big problem is how to make BIM and model BIM on the old road. And for that is then the geophysical system is and like 3D radar technology is very good, and what we've been doing. But how we understand here in Europe and digital twin, for instance, in Finland is that you have a surface, for instance, on the roads and streets. You have a surface model of your roads, and then you have a subsurface information also. But it's not like 3D or 4D. Actually, it's 5D. How we understand that it, as in BIM is that it is moving all the time. So one dimension is always time, and when you are talking about roads, so it's quality also. For instance, fatigue, moisture content, and everything else. So it's a very ambitious system, but definitely worth of moving towards. And it's a lot of work to get it done, but it's on the good database. And for instance, one big issue on this digital twin is that and the problem in Europe has been that what is the database forum and everything else. And actually today on another session, it was now announced that Europe is starting to work on this DPP, digital product platform, that starts to make a open source platform where you can bring all this digital twin down. Because if every country will start to make different platform, it will be a mess. You have to have some common standards, and this DPP is definitely a solution for that.
I haven't heard of this one actually. I've heard of the OGC, the Open Geospatial Commission, and then there's ISO and many different regulations and standards and governance. I haven't heard of this one yet, so this is interesting. And this is across borders.
Yes, it's a European Union project.
Okay, interesting. And do you think regulation is moving fast enough to keep up with the innovation in this space?
At least in Europe, what we've been working on in sort of digital twin and with the 3D modeling of the structure. So it's not, and it's not only, it's not my opinion is that it hasn't been only government issues. It's been at least in about 20 years, I found out that even all the companies who were making CAD software, they had the different issues, and they were very much afraid of what happens to their own product, and that was a burden for development. But in that way, it is not that the guidelines are made in EU. Then all the and as I said, that this DPP is an open source system, so it will be a flexible and it will not become a specific business for any manufacturers or system developers.
Understood. So in terms of what surveyors should be watching for, it is this platform right now would be the one that people to keep an eye out for. Or is there others?
At least that's what I think at the moment, at least here in Europe is going on. France is it's a EU project, but it's leading by France.
Interesting stuff. Have you seen anything like this in from Canada's perspective, Mitch? Any kind of efforts to make data more available?
Yeah, I was listening to Timo there. I really appreciate that top-down approach. It seems important for this because what my experience is, it's more of a bottom-up in terms of our at Tetra Tech Canada, what we're working on, and especially in my group. I'll speak to my experience, the infrastructure group. We have all these types of data that would be very useful to be combining into a digital twin style deliverable for our clients. But of course, to do that requires more funding from the client side, unless we have this integrated whole procedure, which we don't have yet. So there's multiple sort of piecemeal solutions where we give them, you couldn't call it a digital twin because it's leaving out certain important parts, but every client wants maybe one slice, and for us to be over providing doesn't make any cost sense, I guess. Now it makes much more sense. I'm thinking specifically for utilities here, because I find that to be an extremely useful application for this idea for digital twins. From the utility space, there has to be more top-down regulation to make that a necessity, and then the infrastructure for that can be built up. And that's not really happening in Canada. I would say it's more us showing our clients what can we provide you that's more than what you even think you need. So I would say we're kind of farther behind Europe, certainly, and I think most of the DOTs too. So there's a huge amount of opportunity, I think, in Canada for this.
Yeah, I was thinking, these digital twins is a huge promise. I mean, I think it's like Timo referred to, it has incredible opportunity, and we see some enormous steps in this direction. But there's this niggling thing in the back of my mind where data seems to be in silos, so it seems to be remain a barrier. What's the panel's take on that? Is data still in silos? Because I remember in my former position as a practitioner, we would collect, really create these amazing digital representations of the subsurface, and we would do incredible work. But it would just be for us and the client. It would never reach the wider community or world. It was incredibly useful for some clients, for instance, aviation, that had a living and breathing digital twin. It fed into that where it was used. But when it was, let's say, a typical street where we had utilities and we built everything around us above ground and below ground, but it was just really held in a silo. It was never really released for wider consumption. So, are we still collecting great model information, but it's still held back? Is there still a barrier?
Well, I'll speak to my experience. There certainly is a barrier there. The way you could almost say the things that we do provide to our clients are flattened versions of digital twins, almost, where we take information that's collected from FWD trucks or PSPs or LCMS and GPR, and then information that is interpreted separately from all those different types of data, and then combined into, maybe just an Excel sheet or a GIS deliverable or something like that, where it's a synthesized version of each one of those. So you're not really getting all the information from each data set. Now, there's challenges. I've thought about this from a philosophical perspective. There's challenges if you provide all of the data, because a lot of it needs to be filtered through expert analysis before it can be just given to somebody. I'm imagining someone with an iPad, in the augmented reality sort of thing. What they're seeing on the augmented reality isn't the raw data. It has to be filtered through people first. So it can't be automatic, I suppose. There has to be some synthesis behind the scenes, and there has to be a real overarching philosophy from us that intends to combine these, because oftentimes, unless it's in the intention of the project, the data sets are not collected in a way that they can be reliably merged, actually.
Yeah, and then scalability becomes another recurring issue. Yeah. So how can organizations build twins that grow without becoming, unmanageable? Let's say we could have a digital twin that covered, all cities, for instance. How do we grow without becoming unmanageable? So let's take a moment to look at some case study examples, just to put some graphical information on the screen, which will break up just the questions. And Timo, you have some nice practical examples. I think would be really nice to show.
Yep.
Thanks.
The screen. Do you see right now my screen?
Yeah, got it. Thank you.
Okay. So here's only few examples that how you can make a digital twin of the surface and subsurface structures, and talking about this like what Mitch was telling about the silos. So I would say that here in road scanners, we've been working, trying to work us with the road doctor out of these silos, that we've been trying to make a software platform that you can integrate and view and analyze all the data, pretty much any kind of data what is collected from the roads, surface and subsurface, and also technical information like modular values or stiffness, and look them in the same view, but continuing still on that silos is that the big challenge is that how do you can import that then to the CAD software and the others, and for that this DPB could be a great solution. Anyway, here's an example of how we understand digital twin is that this is a road 194 from southwestern Finland, where we collected LiDAR data and videos. From the LiDAR data, we calculated in this demo, it is a rutting information, which means deformation, and then we combined the cross section. So there are 3 runs with the Kontur antennas, 4 runs with the Kontur runs, 2 runs each direction, and then we combine them to a cross section. And this cross section on the right hand side, you can see then integrated also the surface is linked to the real surface, so you get an 3D idea about how this looks like, and let me see if I'll just click a couple of places how this then look, and for instance, this is a quite nice example that if you think that our old roads are homogeneous roads, and that you are running one GPR line, and then you think that okay, this represents the whole road section. So that's definitely not the truth. So roads are historical structures, and they've been widened, and like in this case, there has been a big settlement, and then on the left hand side, it has been excavated, the settlement away, and while building bridges and everything, and you can see even old asphalt, roughly 50 centimeter deep structures, and then like geotechnical issues is there. So it's a very challenging information, and without this kind of information, it's really difficult to get good idea that okay, what's going on, and especially, for instance, one application on this kind of digital twin is that if you start to widen the road, and then you have a you need to know how much there will be a settlements in the embankment, so you can look at the old road and get an idea of what is the amount of settlements on soft clay areas you are developing. And also very nice about the cross section. So you should have here, for instance, very nice crown crossfall, but the road has been severely settled in the road center. So and in sometimes in these cases, so even U shape. Anyway, another example is what we find very nice to represent and showing the benefit on the digital twin is showing material properties like moisture content, what we can calculate from the GPR data. We have this moisture damage index calculation protocols in Road Doctor, and here's just example of highlighting the importance of drainage structures, and in this case the outer slope of the road have material from the outer slope have been flowing towards ditch bottom, and it's blocking the water flow, and you can see moisture from the ditch is now infiltrating under the road structures. And once there is a moisture, then you start to have a deformation properties on the road. So this kind of helping asset management and proactive maintenance to make correct solutions. Then third one, we were talking and we heard already about utilities. Example is this is from hometown Rovaniemi, and there was a big problem with the leaking water pipes. So what we did was that we made a point cloud, and from the point cloud we took the utility data where they were supposed to be, and that's also one experience on the digital twin, that we have quite much cases that the water pipes in some cities are not even close where they actually even close where they are. But in this case, the problem was leaking water pipes, and so we analyzed GPL slot and made time slices and made the moisture analysis, and here's one, for instance, one potential area. Actually it was made and checked, and they found leaking water pipes on this section. So you can analyze moisture, and that helps you to locate also. So it's a tool for general maintenance management. So we have a lot of examples from the airports also and bridges, but I just now wanted to show you these three ones. So thanks.
That's great. Thank you, Timo. So while we're on the subject, let's quickly talk about tools. So what innovations are enabling digital twins to move forward from concept to reality? We see a couple of different tools that you've used there, of course. So what innovations are enabling us to create these digital twins? Bill.
Well, of course, there's using ground penetrating radar systems for determining depth to utilities has been a pretty important development on our side.
Sure.
So we've been using that on a project level basis for a number of years now. And so one of the things that we've been doing is using that to determine utilities on our maintenance stations ahead of construction, and providing that information to our designers to help them determine utility, to identify utility clashes and help them with identifying issues that can be taken care of, whether to protect in place or relocate, or to redesign or avoid existing utilities at our stations. Has been a big boon for them. And I know that's been a big savings. I mean, the estimates, at least on a national level, has been anywhere from 5 to 25%. construction cost savings can be realized through the use of these digital twins and the process of building information modeling. So those are very, very that's nothing to sneeze at. Those
No, it's
numbers
tangible. Yeah.
are substantial, especially when we're talking about something like a state transportation department where we're spending billions of dollars on construction every year. You know, those savings are pretty significant.
Absolutely. And Timo, we saw point clouds in your data, which is becoming more and more common to combine with geophysical surveys. You guys have been doing
Yeah.
that for some time, right? So it's
Yeah.
nothing new to you.
Yeah.
But it's
Yeah,
becoming more
it's
common.
nothing new. So, yeah, it is. Of course, one issue what we are like doing quite much to get acceptance also over there, and for that it is what we call descriptive showing data analysis. Not only Excel sheets, but visualizing to the client who are not so much expert on geophysics and everything else, visualizing where, as I try to show you that even the maintenance crew who is handling, they understand that okay, this needs to be clean, and in that way it helps to sell this product. And that's so. And if you are talking about this driving new drivers, I would say AI is one, definitely. AI is exactly like a system that helps to view huge amount of data and in X, Y, and Z, and then time and whatever. I would say that AI will be a major booster on digital twin over there.
That was going to be my next. That was going to be my next question for you.
Yeah, and a couple of others where I would say that that some other issue is for instance autonomous driving is one issue where you need to have a digital twin, and I guess you have heard that this electromagnetic fingerprints from the roads that was developed by GSSI is a great idea. We tested in our ITS test platform in Finland about that, and it works. Really works well, and there could be very good like a driving force for geophysical and digital win, and in general. Third thing is asset management is now really like moving forward, and asset management is together with AI is understanding that when you put them. And finally, one interesting just example that I heard also today here in Sofia is that now this European Union, there are some sustainability goals, and one interesting issue was that there's a project going on for bridges, older big bridges that they will be refabricated, which means that part of the bridge structures that are still okay. So if the bridge is not demolished and crushed totally, but they are taking the good part of the bridges and building them to another places. And for this kind of application, 3D GPR would be just perfect. You can find easily the sound areas and help for designers then to say that okay, here's a big part, the good part of the bridges, and we don't demolish that and change to another part of to another road. But that's my ideas on that.
Yeah, absolutely. I really like the concept of having sensors just on public transportation vehicles that are doing the same routes. I would love to see that realized, because then we have repetitive data sets, then we can really monitor assets over time, which would be a huge step forward. And I think AI is an interesting opportunity that could reduce the amount of manual data interpretation we would have to do. Yeah, huge subject. And Mitch, what do you see in the technology and innovation
yeah, it's an
category?
interesting. Yeah, I was going to bring up in this context, and then I'll quickly transition to the AI discussion. We have at Tetra Tech, we have a mapping technology called Fusion Map that my medium term goal maybe is to integrate with just the GPR. We already use it for mapping some other things, and so this is a natural way to kind of introduce digital twins to some of our clients, and some have been more interested than others. Some are just the more bureaucratic minded clients might be just like, give me the answer. I don't want to be floating through a cloud space in a map. But then for some people to kind of see the vision. So that's something I'd like to get into. However, the way we collect the GPR data, at least I have been, doesn't naturally integrate. And I've had some conversations about how to fix this. But we have maybe one way to collect this data, another way to collect this data, and they actually don't mesh when we're trying to put them in the overarching scheme. So it all has to be, like I mentioned, top down from a perspective of regulations. It also has to be top down management, from a management perspective, because to do this, we're a big company and we need to be integrating all of our different groups who do work on different projects for different reasons. So we need to be able to have one standard across the entire company almost, if this data is going to be integrated, which is actually hard. It's hard. There's a lot of people involved in doing that. And if we just had one person in charge of this, then we'd be probably losing a lot of individualized work where we don't really need to be delivering digital twins for everything. It's really overkill. I was also thinking about the application of this. I don't know. This is sort of a thought just kind of occurred to me this morning, but people talk about population change, and some cities are growing and a lot of cities are not going to be growing anymore. But we still have large, complex cities that need to be managed, and to do that in an efficient way is going to be, I think, increasingly important over maybe on a decade's time scale. It's going to be really important that we can manage a very large, complex city built for more people than live there. That's otherwise it can get quite dangerous, especially with utilities. But then, okay, transitioning now into AI, and I'll just say one comment and then pass it on. But looking at what we're going to be talking about in this panel, it reminded me of the sort of famous 1979 quote from IBM that a computer can never be held accountable. Therefore, a computer must never make a management decision. So that made me think, never make an asset management decision. It's absolutely true. And we already all rely on AI to varying degrees. I do too. But when it comes to, especially I'm thinking about utilities, we can't, there has to be a human that looks at it ultimately. Even if there's so much data, we need to be moving efficiently with AI, yes, but we have to be careful before we start opening up the ground. Anyway, I'll pass it on. Absolutely.
Bill, have you used any AI tools in your practices you've been doing so far?
Well, yeah, we have not been involved directly in the use of LiDAR and digital cameras for asset extraction, but our surveys units within Caltrans have been doing that for some time now. Just automated identification of assets and pulling those in, even going so far as to doing reading paddle signs, for extracting information on things like culvert assets, things of that nature. From our side, on the ground penetrating radar side, we've used some of the machine learning tools that are available through Kontur to do anomaly detection, and also for coming up with identifying pavement thicknesses, and those resulted in some significant cost savings for us. I mean, they've kind of, in many respects, they've kind of revolutionized how we've been thinking about how we do our business. So instead of dedicating massive man hours to try to come up with all information that we can extract from ground penetrating radar, we think, well, maybe what we need to know is we just need to know where things are different from the surrounding roadway, and then flagging those areas for follow-up. And so that's been a big kind of sea change in how we do our job, and it's resulted in quite a bit of efficiency.
Yeah, yeah, of course. I mean, there's a lot of hardware advances, but there's an enormous amount of software and analytical change going on right now. Of course, we're involved in that, and it's demand from our customers, you know, to try and get that stuff done. And yes, we're using machine learning. Part of what Bill's referring to is Kontur Orbit. So we're working on and have released this year ways of mapping the subsurface materials, the layers of the subsurface in a more efficient way. So using machine learning models to take some of that hard work that you guys do and make that more automated. But then harking back to what Mitch says, there is a QC process in there which is human, so it's not completely out of your hands, of course.
Yeah,
and yeah, go ahead, Tim.
If I can add also that it is like old saying from the GPR veterans starting to work on GPR on 80s already, and that we were telling that time that GPR itself is not as intelligent that it cannot lie. So GPR doesn't lie, that they are the interpreter, but AI is coming, and you have to, I agree that you have to have a human control, but not all the, if it's expanding this use of GPR is very much so. There are not enough GPR specialists to analyze everything else, and to a certain level we need to start to trust on AI, and of course AI analysis also with a certain, like probably some kind of risk factors with that, and finally, yeah, of course, a little bit news also on the road scanner side that within next few weeks we will publish also the first AI version of Road Doctor. So it's moving also on our side.
Yeah, fantastic. And so let's look ahead. Let's what is the next what is the next frontier? Of course, we have AI. Is it real-time simulation in these digital twins? Is it predictive modeling, or is it something else? What can we bring into these digital twins? Predictive modeling would be something interesting, especially for pavements. Something that would predict the future. What's gonna happen next to this pavement would be an interesting concept, right?
Yeah, this is what we've been doing and developing, working in this proactive maintenance project, what we've been doing last 10 years. Since 2015 we started this project, 3 big areas in Finland, monitoring with the GPR every year, every lane, and now we have been we see what happens also on the GPR data, and for instance, one very nice like promising application is detecting micro cracking, non-visual cracking, because we know that before pavements crack, it develops last 500,000 axles. Before that, depending on the traffic volume, you are having micro cracks. And if you are doing chip sealing or repaving on the micro crack areas, and the new pavement lifetime can be 7 times longer, and life cycle cost according to our experience can be 60% lower. So basically, when you are detecting visual cracks in the modern asset management, you are checking how late you are with your measures. and in that way, like the GPR, which is you could calculate that, and like what we've been doing is we developed this microcrack system for nuclear waste disposal site, where it's extremely high specification that you cannot have any kind of cracks for nuclear waste areas, and it's the only accepted system for nuclear waste disposal is the GPL. So we know it works, and the results are very promising. So as you said, Paul, that you could predict the future now with the digital twin and GPL.
Yeah. And Timo, you raise a very good point about the predictive modeling and how essentially evaluation of cracking is kind of putting you behind the 8 ball. You know, you're actually kind of lagging your analysis, you know, for predictive maintenance. And you know, here at the Department of Transportation here in California, that's exactly how we do our predictive maintenance modeling, is by looking at the development of rutting and cracks over time on our roadways and trying to estimate remaining service life based on that. So we've bounced around the idea for a number of years of how we can bring the ground penetrating radar information into that, both in terms of microcracking and in terms of looking at maybe changes in dielectrics over time, looking at trying to extract that additional information from the radar data and incorporating that as part of a network level analysis. And we are nowhere near the point of adopting that, but we're at least trying to consider how that might be brought into our predictive maintenance models.
Thanks, Bill. Okay, we are 10 minutes out-ish. So I think we can, I'd really like to try and give some advice to, companies that maybe are starting out, maybe considering the first digital twin type of project. What would be your, one piece of advice to a company that is embarking on its first digital twin project? What would that be if you were just starting out now to create something that would be considered a digital twin? What would you need? What would your approach be?
I think that's a good way to start, is to start very targeted and small. Just thinking about what Bill was saying there with cracks, that's something that we do as well in Canada. We do a lot of crack work, and just the very simple problem of combining the surface, laser scanning information for cracks with the GPR, just that information alone. So we're only doing 2 different types of data sets to get extra context. If you can just master that, that's pretty good. And then layering on one thing at a time. I think sometimes with the conversations of digital twins, we get, we think about knowing everything at all times in this one enormous master file or master deliverable, but it's far too complex for almost all applications and decision makers. You have to have a working knowledge of everything that goes into that, or you have to put your entire trust in it like a black box. So I think starting small, just like I was talking about with these 2 different types of data sets analyzing cracks, so we can see at the surface and we can see maybe at the bottom of the asphalt. Combining those, that alone is a massive, I think, improvement. And if you get that good, get that sorted, then you can add one thing at a time. Make sure you're doing it thoughtfully. Yeah.
Timo?
Yes. I would. In basically, I agree with the Mitch that start with a some concrete project that is not too complex. And for instance, I remember some areas that, for instance, in France, there was a highway where the road shoulder was a different structure, and it was widening, and nobody knew where this old road shoulder structure, what was cement stabilized, So yeah, because geometry was widened also. So just driving with the GPR and finding where the structure and the structure changes in the road cross section was the valuable. It's a compact, relatively easy to do with the 3D radar type of system, and customer satisfaction value very good. So you get encouraged to use that. The other issue, of course, is finding some special structures, like very much we have a lot of like concrete structures on old concrete roads, and not very well documented where these concrete roads structures are, and finding their like their areas and their locations. This kind of is also, but like a compact smaller project, and also keep in mind that if you are talking about, don't take a project where you have to drive full speed. If you have to make a 3D model, the positioning we haven't talked too much about. That if you are putting 3D data, 3 or 4 3D data, as I showed in my example, to get all this data match with each other, that it doesn't look totally crazy. It's a challenge, and that in that way you have to have a good positioning and don't drive too fast.
That's a good tip. Yeah, that's a good tip. If you're creating something that is a model, positioning is key, and data quality is everything. And if you go at it at 70 miles an hour, you might find that you struggle initially. So build speed over time, I think, is a very good. Is a very good. You start small, start simple, like Mitch was saying. Not too many layers of information, and also start slowly in terms of collection speed, because positioning is key if you're going to build something that has to have accuracy when you're overlaying your information. You're absolutely right. Closing engagement. Just to if you could describe the future of digital twins in one word, what would it be, and why?
Yeah, well, I think from the California side, we're moving towards adoption of the building information modeling and creation of digital twins, where we've got pilot projects underway, and essentially within the next 3 to 4 years, our plan here within the state of California is that every future project will be using building information modeling. So we will be developing digital twins for construction, and then post-construction, those digital twins are going to be part of the asset information model. So we are moving full tilt, and in many respects we have no choice. We've been mandated. We told you we will do this, so we're moving forward with it. Some of the biggest challenges, though, are that we're going essentially from a 2D paper plan to a 3D digital design, and and as we demonstrated, there was a building information modeling summit in March that was held here, and Caltrans participated in it. And one of the topics that came up was that it was recognized that the construction industry essentially remains risk averse, in part due to their experience with inconsistencies in these digital models. So what we need to do is essentially identify part of the process for quality control on these is identifying what model elements are uncertain, which elements need to be validated in order to build confidence in them. But we're moving forward. We've gone from essentially baby steps to walking, and essentially by 2029, the plan is to be running with this plan.
Awesome. Mitch?
Yeah, when you asked that question, it made me think of all the different challenges that immediately come to mind. Integrating different data sets, they're not all high quality. What every limitation, is it made clear when you're looking at the digital twin, what the limitations of each data set are? All these millions of different things. And I initially wanted to say, it's a long way off. Especially where we are in Canada, I'm thinking of utilities and how often when construction projects are delayed by utilities, they don't even have anything close to a digital twin to run off of, let alone even 3D GPR in most cases. So that made me first think of all those challenges. And then I was thinking about how that's kind of how I felt when Google Maps first said they were going to map the entire world. I remember thinking that's impossible. It's not going to happen. But with the right energy and vision, I think it could be really revolutionary and really save an enormous amount of time and effort if we do it properly.
Yep. And Timo, closing thoughts?
Yeah. I think digital twin and BIM system. There's like two issues. Digital twin and BIM will move forward on the recently or currently built or recently built roads and infrastructure in general. But still the challenge is the old infrastructure. How do you do that? How do you combine all the issues? And as I've been a few times already said that it has to be top experience it has to be top down process to go through. And now, for instance, what I've heard here in Sofia today seems to be very promising, that if we start in European level, so there's a chance that we end up fighting with each other, and that whose system is the best one, and everybody has to accept that their system has to be made compatible with the general system, that everybody is happy, and that's the future. It takes time, but I think we are now in a very promising track.
Perfect. Thank you very much. Okay, well, we're nearly at that time. So I'd just like to, of course, thank our panelists for such an insightful and grounded conversation. We've covered a lot, from defining what digital twin really means and the context of geophysical and surveying work, and exploring some practical challenges of data quality and integration and scalability. And thanking everybody who joined us. Thank you for your time. And finally, I'd just like to let you know about Examiner 3.9, which is available. So please download it and upgrade your projects. And finally, where to meet us next, we will be at ERPUG in Lisbon, Portugal, at Trimble Dimensions in Las Vegas, and then our yearly meetup at TRB in Washington, DC in January. Finally, thanks again, and we'll see you at our next webinar. Thank you for the panelists. That was really, really nice, and we appreciate your support, and enjoy the rest of your week. See you next time.
Thank you.
Thank you.
Bye, guys.
Thank you.